Yeah, because otherwise you will be going somewhere that you don't want to go.
Yes.
I can almost fit under a 18-wheeler trailer.
You just need to chop your windshield.
That's right. The A-frame is the only part. My roll bar is actually lower.
See? What's funny is they do in the Fast and the Furious, they drive the Hondas underneath the 18-wheelers and stuff. I'm like, there's no way that those would fit underneath those. Stock line.
That'll be pretty hard because the Miata is pretty low already, and mine is lower by about an inch and a half.
And it still won't make it underneath.
No. I can tell, just visually, I can tell it won't.
So what kind of Hondas were they driving?
I think they were driving Civics or something like that.
Yeah.
They're like underneath the 18-wheelers.
Why would they be driving Accords, right? I mean, or minivans.
Yes.
That would be funny. They could haul a lot more gear in a minivan, though.
The S2000. Isn't that the competitor for the Miata?
Yeah.
The S2000 is the Miata. It's faster than the Miata and has better handling because the frame is more rigid.
Oh, okay.
Yeah, so it's a better car. But it's more expensive too.
Yeah.
It's more expensive, and you don't get all the replacement parts either. There are tons of Miatas in the junkyard.
Yeah.
Yeah, you can probably put a new Miata together just by spending a few days in the junkyard.
So pick up a rock, throw it.
Hmm?
Within 10 feet, there will be a Miata.
Yeah. And have not having to spend a lot of money.
Yeah.
All right, so let's go ahead and get started. I finished grading the first question of exam 2. I know it's very slow, but it's getting done. I'm putting as much time as I can on the grading of the second exam. So when you check your grade in Moodle, you will see your grade of the second exam, but because only the first question is graded, so your entire grade of the second exam is only on the first question right now. I'm working on the second question, so it'll be updated hopefully before Thursday. All right. So what we're going to do today is to take a look at types and records again. And this time we'll take a look at, remember last time we talked about how we represent time, human readable form, and how the computer, thinks, that's not really the best way of keeping track of time, because given any two dates and time, it's really hard for us to figure out, the number of seconds between those two timestamps. Are there any questions about that particular aspect that we talked about on last Thursday? No questions? You guys are all very quiet today. So if there are no questions, I'm going to go ahead and start to write some code, making use of the timestamp record type, and then just try to figure out how do we calculate the number of seconds since 1970, January 1st midnight, so that we can compute the computer timestamp from that perspective. Any questions at this point about what we are about to do? Yep, go ahead.
Why didn't they use the timestamp and just update it to like a more current time, like 95, 1990? Why did they keep it like 1970?
Because it doesn't really buy them anything if you update it to, let's say, 1995. The number would change, but then you have to change everything too, because there are mainframes running right now that have files that are created way back when. So if you change the time base, then all the timestamps will shift by the number of seconds between the new exactly. Windows or DOS, everything that's Microsoft uses a 10-year later time base. So with Microsoft products, the number of seconds is from 1980 January 1st midnight instead of 1970. So it depends on the operating system. Okay, that's a good question. Does anyone know how star date is calculated in Star Trek?
No idea.
Nobody knows.
Constellations. That's why it's called star date. Constellations.
Constellations.
Yeah. I know them all. I don't care.
It's pretty hard to do, any type of time in that sense because, time is relative. So, it's pretty hard to measure, time when you're trying to deal with, a big universe. All right, so this is not what we were working on. So let me save this file first. It belongs to one of my other classes. So don't worry if you don't know what this is about.
Oh my gosh, that's what the next test looks like.
All right, so we'll go ahead and get started with our stuff today. And we'll start with something simple. We'll start with how do we calculate whether a year is leap or not. Okay, how many people know the rules of leap years?
Every 4 years.
Every 4 years, and then
Every century that is one.
every 1 century it is not a leap year, and then every
3.
I think it's every 400 it is leap again. Well, we can look this up pretty easily. This is not something that we have to memorize because
Wikipedia.
exactly, just ask Google and Google will link to Wikipedia, and then we can figure out the algorithm. And here we have the pseudocode all done for us. Not quite in the format that we use in this class, but pretty close. The modulo operator is our mod operator. So everywhere you see modulo, you just replace it with mod, and we have the answer. It doesn't have the end if, and so on, with this code here, but we can probably simplify this a little bit so that it will work for us. Okay, so I'm going to keep this one up when I work on my own code over here, and we'll do it this way. All right, so this is our first subroutine. Define sub is leap, and all we want to do is to find out, is that year a leap year or not. We will have a local variable. We'll call this local variable the answer, and it is a Boolean. So we are starting to use this notation using a colon to separate the name of the variable from its type. So in this case, we know the local variable is of the type Boolean. Anytime you see me try to put a number into it, it's wrong. Okay, I should not be putting a number into it because it is supposed to be a Boolean. Right, now there's a way to really quite help to simplify this logic, because we can have a default value in answer, and then we just have to update it if we want the answer to be opposite to the default. But we'll just go ahead and follow the logic completely. So we'll say if, we also need something else. We need a by-val parameter, which is our year. I will use y to represent year just so that I don't have to type as much. And also it makes the code more readable because I don't have to use a wider column in that case. All right, so we'll say that if y mod 4 equals 0, then we have to check something, and we'll say what do we check? We have to check whether it is also divisible by 100. Okay, so we say if y mod 100 equals to 0, and then we also have to check if y mod 400 equals to 0. All right, then what do we do? In other words, okay, without the indentation, it's a little bit hard to read, isn't it? Do you guys want to put in the indentations? So let's go ahead and put the indentations back in, starting from the first line. So I don't know how long this code is going to be. I'll just go ahead and indent this much. These two lines are inside the big conditional statement, and this one is inside the second nested conditional statement. So what does it mean when I get to this part here? It means all of those conditions have to be true or false. They all have to be true, right? Because they're all within the then portion of whatever is containing it. So that means by the time I get here, y mod 400 is true. Is that right? Okay. But this logic is actually kind of cumbersome. Okay, why is it cumbersome? Don't you think by the time we know that y mod 400 is true, that it also has to be divisible by 4 as well as 100? Yes? Okay, well, let's go ahead and change the program. In other words, I think the pseudocode given by Wikipedia is a little bit more tedious than it has to be. So I'll do it a little bit differently. So I'll say if y mod 400 equals to 0, then what do we know for sure? Is it leap or not? Well, let's look it up. And it is a leap year. Okay, so we say, answer gets true. All right. How about the else part? What does it mean when I say else here?
Means that it's not a leap year.
Meaning it's not divisible by 400. Now, if it's not divisible by 400, maybe it is still divisible by 100. Okay, so let's check whether it is divisible by 100. So we say else if y mod 100 equals to 0. Okay. If that is the case, then the answer is false, because if you have a year that is divisible by 100 but not divisible by 400, it is not a leap year. And that's why year 2000 is kind of interesting, because year 2000 was actually leap. It was not, well, let's see. It is leap because 2000 was divisible by 400. The next year that would be kind of weird would be 2100. Depending on medical sciences, we may all live up to see that year. Some of us may not want to live that long. Okay, how about y mod 4? If y mod 100 is not equal to 0, then we'll check y mod 4 and see whether the year is divisible by 4. If the year is divisible by 4, is it leap or not? Okay, so we say answer is true, right? Okay, one more indentation and one more else here. What about this else case? What does it mean when I get to here, when I get to line 11? It means it is not divisible by 400, it is not divisible by 100, and it's not divisible by 4. What about those years? The usual regular years. Not leap. So answer is false. Oh, I need to be consistent and use uppercase. Here we go. And one more indentation. And if. Now, even though we have the answer at this point, the subroutine is supposed to return that answer as a return value. And that's why at the end here, we also need a return statement so that we can use the invocation of the subroutine inside a conditional statement if we wanted to do that. So we just have to say return answer and end define sub. Now we have our leap year determination subroutine all done. Do we have any questions about this logic? Yes?
What is this y mod 100? How does that trace, or what does that mean?
Y mod 100 is the remainder of y divided by 100. We talked about the mod operator when we talked about factoring. So we're just reusing that operator. In Wikipedia, it has the proper name, which is modulo. Modulo is the proper name. Mod is kind of like an abbreviation of modulo. All right. Well, once we know whether a year is leap or not, we can now try to determine the number of days from 1970 up to a particular date. Okay. Are we doing okay so far with that? Okay. Well, maybe we'll just do something a little bit differently first. Maybe we'll just go ahead and count the number of days from a certain year to the beginning or the first day of another year. Okay? Because we want to break it up into big chunks. We don't want to have to count months just yet. Okay? So we'll define another sub, days between years. That's all it's going to calculate. If you want to calculate the number of days between two particular years, how many parameters do you think I will need? Well, let me say
the date of the first year, the date of the second year.
The year, the first year and the second year. Each one is only a year and not a date. You can also make it a date. It just gives me more information that I need, but that's fine. Okay. So that's okay with me too. Question?
Yeah, date and the year.
Just a year. Because I want to calculate the number of days between 2 years.
Be 2 years.
Yeah. How many days are between 1995 and 1997?
You gotta calculate the leap years, then you gotta calculate.
Yep.
the
That's why we have the leap subroutine.
Yeah.
Okay, very good. So we'll go ahead and say, bival y1 as the first year, bival y2 as the second year. The reason why I'm not going to use a date here is so that if we are only interested in measuring the number of days between years, we can use this subroutine without having to create date variables.
Are we assuming that when you say like bival y1 is a year, that's the January 1st year? That's the start date of that year?
That will be the beginning of that year, January 1st, midnight. Yep. So it'll be from January 1st of Y1 to January 1st of Y2. So that's kind of tricky because that means, the year, the Y2 year itself does not count. If Y1 and Y2 are the same, that means it has to return to 0 because the number of days from year 2012 to year 2012 is 0. It's the same year. There is no difference between the years. So the minimum you have to do is to have these Y1 and Y2 to have a difference of 1 to actually see a non-zero value. 365 versus 366. Okay. So we'll go ahead and use a local variable, and we'll just measure days here. So you might want to mute the speaker at about 15 minutes into the recording. Yeah, that's gonna be loud. Yeah, you might see your subwoofer hopping around the floor.
Fail.
Do they fail?
No, it's just fail.
Fail.
Fun. It'll be fun.
Oh. Okay, so we have integer as the number of days, and what we'll do here is we are going to loop through this. So we have another. Well, I guess I don't need another local variable here. We'll go ahead and use a loop. We'll say as long as y1 is less than y2, do the following. And I forgot to do one thing first. We have to remember to initialize days to be 0 because we are counting from 0. As long as y1 is less than y2, let's go ahead and say the days get days plus 365 because we know that every year has at least 365 days. We only need to know whether we have to add one extra day because it is leap or not by using the subroutine. So we'll say if invoke is leap, and then we have to use y1 to specify parameter y in this case. If this is returning true, then we can say days get days plus 1 because that year turns out to be leap. And then at the end of this, we say y1 gets y1 plus 1 and while. Let me fix the indentation, and then we'll take a look at this code again. Return days and leap myself. Okay, everything is inside the loop here, and then within the loop, we have a conditional statement like so. Okay, let's focus on just the logic from line 19 all the way up to line 26. Because we want to see whether this actually calculates the number of days between two particular years. The loop, the condition of the loop is saying as long as y1 is less than y2, we'll continue with this loop. So what if I give you, as parameters y1 equals to y2, they're both 2012. It doesn't get into the body of the loop at all because y1 is less than y2 is false to begin with. And that means by the time it gets to the end to return days, what is the number or the value of days? It will be 0. But that would be the right thing to do because there are 0 days between year 2012 and year 2012. So that part it does right. Inside the loop, at the end of the loop, I have to increment y1 because otherwise this becomes an infinite loop. Y1 stays the same. If it was less than y2 to begin with, it will remain less than y2 to begin with. That's why I need to remember to increment y1 at the end of the loop. For a particular year y1, it has at least 365 days, and that's why I'm adding 365 automatically. Yep.
So in this case, we always have to put in the earlier year first?
That is correct.
Okay.
Yep. If you want to wrap something around it to check for the range, you can add another subroutine that invokes this particular subroutine, so that it will swap, the first year and the second year depending on their ordering. But I think it makes sense in most cases to make the assumption people will give you y1 that is less than y2. Yeah.
Why did you use a while loop there instead of just a conditional statement?
Because y1 and y2 can be off by 20 years. They can be off by 20, 30.
Yeah.
So they're not necessarily consecutive years. So that's why we need a loop. There must be better ways to do it, because the only years that are in question are, divisible by 4. So I could have, made an adjustment so that, we just have to start with, a year that is, divisible by 4, so that the loop only has to increment by 4 each time, because all the other years we already know they are not leap years. This is a little bit easier to read and easier to understand. So the optimization makes it go faster, but on the other hand, it also makes the code more difficult to understand. So right here, this is not as smart as we can get, because it will test year 1991, 1992, all the non-leap years it will test too, but it doesn't hurt it. Yep.
If you use not equal to, y1 is not equal to y2, would that make the order of the years not matter?
Nope, because if you make this condition on line 20, let me point out using a mouse pointer here. If you make this comparison not equal to, then if y1 is actually greater than y2, the loop will not exit at all, because we're still incrementing y1 at the end. So that means if you want to change this comparison to not equal to, you also have to change y1 gets y1 plus 1 to be a conditional statement, so that you increment y1 if it is smaller than y2, but you decrement y1 if it is larger than y2.
And would that be a simpler way to do it than creating a whole other subroutine?
It is less efficient because you have to do it for every iteration. If you use another subroutine, you only have to do it once, and then inside this loop here, you don't have to do it over and over again. And then there's also a second thing. If you reverse, the order, instead of having y1 to be less than or equal to y2, if you reverse the order, I think you have to change the sign of the number of days returned.
Yeah.
So that means, you're not just incrementing, but you also have to change the sign of the number of days, because that would be proper, right? Because x minus y equals a certain number, but y minus x would be the negation of that number. All right, but for the time being, we'll just use this particular method, and I think it works. It should work just fine. After we add a default of 365 days, we will double check to see whether y1 itself is a leap year. If it is, we'll add one more day to it. We'll add one more to the number of days. Is that okay so far? Okay. If this is all working so far, we'll add some more code. At this point, I think we'll have to start to talk about records. So once again, we'll start with record date. And inside the date, we have y as our year, m as our month, and d as our day of month. And record. And I think I use lowercase record usually. So there we go. All right. That's because the next subroutine that I'm writing is going to make use of the record date. Because instead of measuring the number of days between 2 years, it's going to measure the number of days from the beginning of a year to a particular date of the same year. Are we understanding? I'm breaking up the problem into big chunks. First, take care of the years between 2 dates. Next, take care of the number of days from the beginning of the year to a particular day of that year. So we'll go ahead and write this subroutine. Define sub days to a particular date, in this case. And the way we do this is going to be passing something by, we can pass it by reference because it is more efficient that way. So we say pass by reference. In this case, it is a date parameter that we are passing in. And we also need days here to represent our answer. So we have local variable days as an integer. And this time we also need one more thing, because inside this particular subroutine, we have to count the number of months. Okay? So we have, there are several ways to do this. I'll do it the first way, and you guys won't like it. And then we'll do it the second way. Okay. So let's do it the first way first. Okay. We say days equals to 0 to begin with. All right. Now remember, this is, it's days to a particular date of the same year. So I don't really have to worry about the year unless the date is March or later. Does it make any sense? If it's February, and I'm assuming the date itself is valid, I don't have to know whether it's a leap year or not. It's only on or after March that I have to think about, okay, is this year leap or not? So what we'll do is we'll do it this way. And some of you will not like this approach because it makes the program really long and kind of brittle. So we'll say if d.m equals, now this is another place where you can decide how you want to represent the date. Remember what I said, people in computer science, in programming, like to count from 1 or 0.
0.
We like to count from 0. So January, being the first month of the year, to most programmers, in their mind, it should be a 1. It should be a 0, not a 1. However, because we also write January as 1 when we write a date, in numeric form, so most of the time we just use 1 to represent the first month, even though it is conflicting with the usual way of us representing, using 0 to represent the first of something. So in this case, we'll just go ahead and use the convention and say that 1 is January. Okay. If the month is January, then how many days are between the first day of January to the, okay, let me rephrase that. How many days are between the first day of the year to the first day of January? 0. Very good. So we say days gets initialized with 0. So that means this line is not needed because we are going to customize all this stuff here. Else if d.m equals 2, then how many days are between the first day of the year and the first day of February? 31. Very good. You can see how this goes, right? d.m equals 3, which means we're talking about March here. How many days are between? Well, we have 28 at least. 28 plus 31. The 31 comes from January, and the 28 comes from February. And then we have to see whether it's a leap or not. Okay. So then we say if invoke is leap, and I can copy most of this, except we don't have y1 anymore. We have to use d.y, which is the year field or the member year of the date parameter that we are working with. If that is the case, then days will get days plus 1 because it is a leap year. Sorry?
Can we stop right there?
Keep going.
We're gonna do this. That's why I said some of you would not like this, right? Remember that? Okay, what is a better way to do this? What do you think is a better way to do this?
Use an array.
Aha! Use an array because the month is a number. And if we can have a little lookup table to index the month to the number of days from the beginning of the year to the first day of that month, that would make this code a whole lot easier. Then we only have to take care of the leap year and February, and everything else is just one lookup, right? Okay, let's do it the other way now. But does everybody understand why this code is kind of tedious right now at this point? Because I have to do one comparison against every possible month, and that makes it kind of tedious. It's not really brittle in a way because I don't think we're going to change the convention of how many days are in the first month, second month, and so on. So in that sense, it's not brittle because this code will keep working for a long time. But it is nonetheless still kind of long and kind of tedious to look at. Sorry?
It'll work indefinitely. Won't it just doesn't have the Y2K bug?
The Y2K bug? Well, I'll bring that up later. What is the Y2K bug? And
Is there anybody in here that doesn't remember Y2K?
Okay, but what exactly is the Y2K bug?
Basically, people use two-digit year to represent everything, and then when that changed, when we went from the 90s or
1999 to year 2000.
2000, it's just like, well, we need 4 digits now, and everything's wrong.
You got the basic idea. Okay, to us, it's not a problem. Okay, we still have forms that only have 2 digits to represent the year. So when you fill in those forms today, you will just write down 12 because it is 2012. The next person who's reading the form is not going to say, "Oh, I think you got it wrong. It's not. This year is not 1912." Because by context, people know that this is year 2012. But programs do not have, quote unquote, the context that we do. So when a program looks at the year field of a date that only has 2 digits for the year, it will not understand, oh, do you mean 1912 or do you mean 2012? It is up to the programmer to really write the code to go either way. Okay? So why is that a problem? Let's think about a nuclear plant. Okay? Let's think about a nuclear plant that has to schedule certain things to happen. Okay, maybe draining the coolants, retracting the rods, doing all sorts of other stuff, and it has to schedule for like a few days ahead of time so that there's enough time to shut down certain things and things can go very smoothly because they can be done very slowly. What happens when you have to schedule? Okay, let's say today is the last day of 1999. And the nuclear plant control program says, I want to schedule 3 days later, I have to flush the coolant, and do all these maintenance items. Okay, so it's going to use 00 to represent year 2000, and 1 to represent January, and then 2 to represent the second day of January. And there's another part of the program to double check, when is it time to perform all those maintenance items. The comparison that is used to determine is it time yet to perform these maintenance items, if you don't write a code to interpret 00 as year 2000, then that code will think that 00 is a date that has passed already. So whatever you schedule in the future will not happen. There won't be a trigger to make it happen. Okay, and that's the Y2K bug. That is, technically that is the Y2K bug, is the programs do not take into consideration of the rolling over from 99 to 00. Now certain programs can do that. Okay, you can say that the range of this program cannot, we do not deal with dates before 1970, let's just say. So when you have a number, the 2 digits, being 00, you can write a program and say anything that's less than 70 will automatically bump it up by a century, so that 00 actually represents 2000. If you wrote a program like that, then the timestamp comparison logic will still work because you accounted for that particular rollover already when you wrote the program. It's just that in very old programs, they did not think of it. Okay, imagine you're one of those programmers in the 60s or even in the 60s programming the mainframes. Would rolling the year over to year 2000 on your mind?
No.
Probably not.
And even at that point, if somebody did think about it, they're probably like, well, this won't be in use by then anyway, so I mean,
Exactly. Except those programs are still in use. Some of those old programs are still in use, and that's why we have the Y2K bug. And you can also imagine if the nuclear plant control program was written that way, bad things can happen because the maintenance items and other events scheduled for the future basically will not happen. Nothing is going to make it happen because of the comparison problem. Okay, and that's why people were panicking in 1999, thinking that in year 2000 really bad things would happen. But in reality, most programs can be patched relatively easily to take care of that problem. What about the nuclear plants? Do you think any of the nuclear plants was in any danger of doing all sorts of bad things?
No.
No, because they are.
They planned ahead for one.
They planned ahead for one, and then they are mostly not written in COBOL. Now, this part also depends on the programming language, because in COBOL and some of the other commercial, application programming languages from the past, that's when they use, the 2-digit for month, 2-digit for day, 2-digit for year representation. Anything that uses, Unix or Linux, as a foundation, they would use the number of seconds since 1970 as a representation of time. Do you think if you use that representation, year 2000 presents any particular, Oh, here's another one. And the time is 11:05, so 35 minutes into the recording.
You actually need to do is just get some
Sticky.
Velcro or something and just put it down there and Velcro the other side.
It's just slanted, but this problem never happened before.
It's on the other side too. Duct tape.
Duct tape, yeah, duct tape would work. I don't have any right now. I know. I just have to put it on a flat surface. I just have to make sure that I don't walk around too much then. All right. So Y2K is not a problem for nuclear plants or programs that utilize a different time representation like the one that we are working with right now.
Well, that'll eventually roll over too, right? That'll eventually roll
Yes,
over?
that will eventually roll over. Okay, the question is, when is it going to roll over? Very good question. Let's
2038?
let's do some calculations. It's pretty easy. Okay. We mostly use 32-bit numbers at this point. Okay. Now with a 32-bit number, and let's just say that we are only counting on the positive side. What is the largest number that you can represent using 32 bits? 1 bit is a binary digit. It'll be 2 to the power of 32 minus 1 would be the largest value that you can represent. Okay, so we'll represent that number. It's 2 to the power of 32 minus 1. That's the largest value you can represent using 32 bits. Okay, and a lot of programs use 32-bit integers at this point. Okay, so we'll go ahead and convert the number of seconds into hours. Okay, I'm skipping minutes. So this many hours, and then we have 24 hours per day. And for just estimation purposes, we'll just say that there are 365 days in a year. Okay, so that means it's going. Did I do some calculations wrong here?
It's a 32-bit signed integer.
If it is signed, then you have to divide this number by 2, and then minus 1. So that means about 68 years from 1970, it will roll over. So you were absolutely right. From 1970, so it'd be 2048. 38.
38.
Oh, 38. I got my arithmetic wrong. That's why I use a spreadsheet. Because then I can do something like this. 1970 plus. Okay, fine. I think human neurons, should not be wasted, doing, additions and stuff like that.
Right.
I agree.
Tell that to your math professor, right?
Shouldn't have to deal with numbers.
Oh, try inverting matrices when you get to linear algebra.
I'll pass.
I wrote a program to do that, but I could only do it in my homework assignments. I couldn't take it with me, in the test.
Oh.
Yeah.
could
Just
put in a
funny.
graphic.
You would think that the professor would say, well, if you can write a program to invert a matrix, I think you understand how to invert a matrix, right?
No.
I gave you gotta do it one time.
What was probably not clear to the professor was, did you actually write the program? That was the unknown part to the professor. So that's why.
Didn't you put it in a graphing calculator and take that in there?
Oh, I can write the program on the fly, and describe it to the professor, but it probably doesn't work that way. In year 2038, sometime within that year, we are going to roll over a 32-bit number. Now, when you run out of positive numbers with a signed 32-bit number, it will go to the most negative value, which means it will go from about 2 billion all the way down to negative 2 billion or so. So in terms of actual time represented, it'll be 1970 minus 68 years. So we'll be back to 1902 or so. That would be very bad. Okay? But it's an easy problem to fix because, what type of Windows are you running? When you buy a new computer, is it going to run 32-bit or 64-bit? 64-bit. Okay, so let's think about what happens when we have 64-bit numbers. Okay, so all we have to do is to copy and paste this a little bit, and we change this number because we just have to change the power. Instead of 2 to the power of 32, we change it to 2 to the power of 64. Doesn't sound like a whole lot. I mean, 64, 32, it's all the same. Maybe double, okay? Maybe we'll just double the amount of time before it runs out. So instead of 2038, it's going to be 2038 plus 68, which is 2100 or so. Okay.
Oh yeah, of course.
And then you look at the number, it goes like, I think we got enough time. The sun is going to expand, become a red giant in about 2 billion years. That's a little bit more than 2 billion. 2 billion would be 2 point something to the power of 9. So that's about 100 billion years. 200 billion years. Yeah, the sun would be dead, and, we'll be moving on to somewhere else.
It's fairly close to 3 billion, or 300 billion.
Yeah, it's close to 300 billion. And,
I'm pretty sure
the
by that
universe,
time we'll have
as
spaceships
far as
and
we
stuff
know,
like
this
that
universe is
floating
only a few billion years old.
around.
So that's quite a long time. Yep.
The Andromeda galaxy will crash into our galaxy before that.
Oh, way before. Yeah, the Andromeda galaxy is going to collide with our galaxy in, is it about 1 billion years old?
About.
Yeah.
Oh my gosh, it's doomsday!
It's okay, we live in the suburb part of the Milky Way galaxy, so maybe we'll be okay.
Maybe. we'll move.
We just need
We don't kill each
to.
other
We
by
just
then.
need to develop warp drive by
I think
then.
humans can kill ourselves, far more effectively
yeah.
than galaxies colliding.
A lot quicker.
Well, galaxies actually have a lot of empty space, especially when you're living in the outskirt part of a galaxy. There's a lot of empty space. So when two galaxies, quote unquote, collide, and you're on the outskirt part, for the most part, it's just nothing. Now, if you live in the core part of the galaxy, then you have those super huge black holes that holds everything in place. Things can get a little bit out of hand there.
A little bit.
Yeah, make it a little messy.
Sorry. Go ahead.
Just get a little messy in there.
Yeah, just get a little messy. Two black holes, duking it out, probably combining into one in the end. Yeah. But the galaxies, both the Milky Way and the Andromeda galaxies are actually just small galaxies on the small side already. There are much larger clusters of stars out there. So. Yeah, and that's why we have scientific notation, so we don't have to name billions and trillions and stuff like that. We just say times 10 to the power of 60. What is that? I don't know. All right. So by changing from 32-bit to 64-bit integer representation, we will never run out of values to represent time. By that time, I'm pretty sure we have other things to worry about. All right. So let's go back to our algorithm here. Okay, getting back to our task on hand, we want to use arrays so that we can just do a simple lookup instead of a whole bunch of if then else, if then else, if then else to deal with the number of days from the first day of a year to the first day of a particular month. So what we need to do here is to define a global variable. In this case, it's pretty hard to avoid the use of a global variable. So we'll just say days to a particular month is an array of 12 integers. Okay? And then we have a subroutine to initialize it. So we have define sub, initialize days. Let's make it days instead of day. Days to a certain month. To month. And this particular subroutine will not have any parameters because we are not giving it any information. All it has to do is to initialize the array. So inside, there's really not a whole lot to do. We just have to say days to month bracket 0. This really goes back to, should we use 0 to represent January? And I think we should, because otherwise we will be wasting the first entry of the entire array. And we can, now what just happened?
You hit Control plus.
This is the power of exponent. Okay, so now we have to deal with the first month, and then the second month. It depends on how you want to do it. You can do it, kind of like the months to days to month, the previous one, and then you just have to add the month that you're dealing with. In this case, this is February, because when the index is 2, we are representing March. So this is representing the number of days from the beginning of the year to March. So you have to include January as well as February. And then we have, okay, I copied and pasted a little too soon. And then just 2 more. There we go.
It wasn't me.
And this will be 31, 30. How about yeah, you can't do it in an actual program, but since this is pseudocode, we're good. You guys get the concept, right? You get the concept, we're good. Yep.
Do we have to change the dates to month to the previous array entry?
Yep.
Each one of those?
Yep. You're correct. I still have to change those. All right. All right. There we go.
Cedric, the computer knows what you mean.
So with that array in place, that means this particular subroutine to calculate the number of days to a certain date of a year can be a whole lot simpler. Because now I don't really need all this logic here. I still need a conditional statement, but only for the second month of the year, or dates that are March or later. All right. So what are we going to do with days? Days is going to get days to a particular month, square bracket. What do I put inside the square brackets now? Now remember how we initialized the array. When we initialize the array, element 0 is representing January. Okay, but when we are actually using the date type, we are using 1 to represent January. So we have to do a little bit of conversion here. Okay, so d dot m, which is the month that is stored inside the date. What do we have to do with it? Minus 1. That's it. All we have to do is to subtract 1 to offset that particular item. And then we also have to say days get d dot d minus 1, right? Because if the day that we are talking about, okay, let's say we are dealing with January 1st in the date itself, okay? In that particular case, how many days are between the first day of a year to January 1st? The answer is 0. But if you do not do a subtract 1 here, then it will be 1. Because we use 1 in the day of month field to represent the first day of the month. Yet another reason to call the first day of the month day 0.
Shouldn't line 38 be days plus?
Oh, you're right. Yep, you're right. Because we're adding to what we already have. Correct. All right. Now we just have to take care of the leap year thing. But in order to have to take care of the leap year thing, we now need 2 conditions. Okay, this is 1, but we also can just use conjunction so that we don't always have to evaluate this, because we have to say d dot m has to be greater than 2. It has to be later than February, starting with March, April, and so on, in order for this to even become important. And of course, we don't have y1. Y1 is our d dot y. D dot y. Like that. Okay, so if the month is March or later, and this is actually a leap year, then we have to say, oh, just add 1 more day to the number of days. And if return days and define sub, fix the indentations. A whole lot easier without all that, if then, else if then, else if then, else if then. Are we doing okay so far with this code? Kind of. So now we have a way to calculate the number of days between 2 years, the first day of 2 years. We have a way to calculate the number of days from the beginning of a particular year to a particular date of the same year. What have we not, included in this calculation? Seconds, right? The number of seconds from the beginning of a day to a particular time of the same day. But that's a really easy calculation. Let's go ahead and see how easy it is. Define sub seconds since midnight of the same day. But in order for this to make any sense, we need a new record type. So we'll go ahead and say record time. In a time, we have hour as an integer, minute as an integer, and let's say we just have to count all the way down to seconds as an integer. So we say end record. Make sure we fix the indentation. So now we can define our next subroutine. Define sub seconds since midnight of the same day. In this case, what type of parameter should we pass? Do we pass a date type record, or do we pass a time record? Time record? Very good. So we'll say T is a time record. We pass it by reference only to save space, because we don't have to copy the entire thing, using up a lot of columns, because all we need is just a reference to the original item. We're not going to change it. We just want to look at the values of this particular variable. So that's why we're passing by reference instead of passing by value. Okay. Well, we can do this in one single return statement, or if you prefer, we can do it step by step. You guys can choose. Do we want to do it in one single return statement, or do we want to do it, step by step using a few assignment statements? One. Okay. So we'll just use a single return statement. So this way, I don't even need a local variable answer, because the calculation is actually pretty easy. Okay. First of all, we have t.s. T.s represents the number of seconds since the beginning of a minute. I think we can just leave that one alone, because we are supposed to return the number of seconds anyway. So this one is already in the right unit. What about t.m?
Times 60.
Okay, we just have to multiply this by 60. And then we have t.h, we multiply that by 3600 because there are 3600 seconds in an hour. That's it.
Is this assuming that it's using 24-hour time?
Yes. And define sub. Now we have all the individual pieces. We just have to combine all the pieces that we have and then have a subroutine to take a timestamp and return the number of seconds since 1970, January 1st, midnight. Okay? And there's a particular name of that time representation. Let me see if I can look it up and confirm that. All right, epoch. The Unix epoch time. Now, why is it called epoch? What does it mean? What does that word mean by itself?
Is it a really long range of time?
Okay, age. Period of time. Long
Period of time, long period. Okay, epoch. A period of time in history or a person's life, typically one marked by notable events or particular characteristics. Nothing really. Yep. But that's how it's called. You know, the number of seconds since 1970, January 1st midnight is called the epoch time. So in case you want to look up, the name of that time or that format, it's called epoch.
It's date plus %s.
Date plus %s. We can try that. Date plus %s. Yep, you're right. That's a Unix command. We can. If you just press, if you just enter date by itself, it uses a more readable format, for humans. But when you use, plus %s, it uses the epoch format. All right. So what we'll do is, I only want to look it up so that I can name the subroutine correctly. So we will do time. Oh wait, I still have one more thing to do. We have to define a new record type called a timestamp. We did this already last week, but I'm just going to repeat it here because this is a self-contained program. Okay, a timestamp has two components. The first component is the date, and the second component is the time. Like so. Are we doing okay so far? Because now we are dealing with the largest unit that we want to deal with today. So now we have a subroutine called timestamp to epoch. It's going to use one parameter passed by reference, which is a timestamp. And it's going to return a relatively large value. The question is, how big of a value are we dealing with? And how do we calculate that value? Once again, let me ask you, do you want to do it in one single statement or do you want to do it in multiple statements? If you do it in one single statement, it's going to be a return statement that will invoke three subroutines. The three subroutines that we have written, not counting the initialization subroutine. One to calculate the number of days from the first day of a particular year to the first day of another year. That would be the first subroutine. The second one calculates the number of days from the first day of the year to a particular date of the same year. The third one calculates the number of seconds from the beginning of a day to a particular time of the same day. So those are the three things that we have to invoke with this particular return statement. So this is going to be a pretty long return statement, so we'll just kind of have to deal with that. So invoke, and I cannot remember my own subroutine names, days between years. Okay, days between years. All right, so we're dealing with, what do we use to specify y1, which is the smaller one?
1969.
1970. Because it's from 1970 January 1st to a particular date, a year.
Okay.
So that's what we need. And we also need to specify y2. y2 is really just our from our timestamp. So our timestamp is t, inside t is a date, inside the date is the year. And we use that to specify y2. That would give us the number of days from 1970 to a particular, to the year that we are dealing with. But that's not all. We also have to invoke the other subroutine. The other subroutine calculates the number of days to a particular date of a year. So it is days to date. And in this particular case, we have to pass a particular date here. So we can now say t dot d will be used to specify parameter d. And I made a mistake here because it has to be a double-sided arrow. This is passed by reference. Okay. Okay, what do we have so far? Okay, what is the unit of this particular value? Are we measuring in days or are we measuring in seconds?
Days.
We are measuring in days. Okay, so that means we also need to make sure that we are measuring in seconds. So we have to take the entire sum and multiply that by, I think it's 86400. Let me confirm that. It's the number of seconds of it in a day. So we have 36 seconds in an hour times 24 hours. Yep. Okay, so I got that right. Okay, now that we have the number of seconds since 1970, January 1st, to the beginning of a particular day, we only have one more component to add, which is the number of seconds since the beginning of that day to the time that we are interested in. So we just have to plus invoke seconds since midnight. And then this time we have to pass the time part of the timestamp. So it's t dot t in this case, and we use it to pass to parameter t of the subroutine. And that's it. And find sub. You can see the actual subroutine to do all the calculations. It's really easy. It's just one return statement.
Can you expand the window a little bit? See all it's blurry.
Sure. Let me maximize the screen. It doesn't have that much.
The little statement.
The little statement?
The whole thing.
The whole thing?
Little.
Here we go. But this, okay, I just applied one of the things that we talked about way earlier in the semester when we talked about how to design a program. I used Google Map, and also the folder structure to illustrate that concept. What was that concept? Top-down design. Exactly. This is technically bottom-up because I identified the small components to begin with, and then I used the small pieces to build bigger pieces, and then use the bigger pieces to finish the program. Any questions about this? How do we reverse it then? I give you an epoch time, and you have to tell me what is the human readable time.
That's a different subroutine.
Huh?
Or that's a different.
Well, we just have
program.
3 more subroutines to reverse the process. There'll be a lot of mod operations, a bunch of comparisons, and yeah, there'll be some loops too. Are we doing okay so far with this code? I mean, what we are trying to do, and why this works. Are there any questions regarding funky, stuff like this part here? What is t dot d dot y? What exactly is that? Let me just pull this one out of context. Let me just zoom back in so we can see better which portion we are looking at. What exactly are we talking about here? Obviously, we talked about it already. I just want to see whether you remember what this is actually representing. Okay, what is the t? The t is the name of our
Time.
parameter, timestamp. Timestamp is passed to me as a passed by reference parameter. So that's what a t is. What about the d after the t? It identifies a component of the parameter. the parameter t is a timestamp. But according to the definition of timestamp, which is here, it has two components. One component is a date, it has a name of d. The other component is a time, it has a component of t. So when we refer to t.d, the d is referring to the component, the date component. What about the dot y at the end? Within a date, we have, if you scroll all the way back, we have, within a date, we have year, month, and day of month, and the y is identifying the year of a particular date. Yep.
This might be nitpicky, but would it make sense to, if it doesn't matter where we define the record, would it make sense to like define all the necessary records like first?
Yes.
And then go through?
You can reorder the definition of the records. The rule of C is just that you have to define the record type before you refer to it.
Right.
So it can be in any order as long as it is defined by the time you use it.
For a better organization, what do you suggest or recommend?
That's a
Best
whole
practice.
different can of worm. I'll answer that question after I answer his. Go ahead.
Isn't it kind of confusing to use all like the same letters for like time and timestamp and stuff like that?
That's because I was lazy and used T, D, and H, M, S. If you want to make your program more human readable, you would have used hour, minute, second, and here you would use date, time, and then here you would use year, month, and day of month. So that would make your program a whole lot more readable, but that would also make this statement even longer than it is. Yep.
In the second part of the relevant return statement where it says invoke days to date, what is t.d? Should
Okay.
it be like t.d.d?
Nope, it is t.d just fine. Okay, let's focus on this one. The t identifies the name of the parameter, which is a timestamp. Within a timestamp, it has two components. The first one is, oh, you're right. Okay. Days to date. No. I was right. Okay, because we have to pass a date to the d parameter of days to date.
Where is that?
It was defined up here. Days to date has a pass by reference parameter, and it has to be of the type date. So that's why t.d is correct in that case. The last one has t.t because we need the time portion of a timestamp. So once again, this particular, because I only chose a single letter to represent, the name of the members, and that makes it a little bit harder to read. So if I had chosen, date instead of D, that would make more sense. Yep.
Going back to t.d.y on line 59. So back on line 54, D is specified as date. Does that record just automatically know because you specified it as date to refer back to the first record?
Correct. Okay, how it makes that association is this. The compiler or the interpreter, of a real programming language will first see T because it reads from left to right just like we do. When it sees the identifier T, it will look up and say, okay, do we have any variables or parameters of this name? And then it finds, oh, yes, we do, because we have T as our pass by reference parameter. That's how it first finds, it resolves the first symbol. Then it will say, oh, here's a dot here. The dot is representing apostrophe S. Okay, let's see what part of parameter T do we want to access. And so the compiler will try to interpret this part of it. Okay, so what it does is it will first find out what is the type of T. T turns out to have a type of timestamp. So the second part, which is .d, is saying, do we have a member called D in a timestamp? And the answer is yes, we do, because a timestamp has two members. The first one has a name of D, the second one has a member called T. So D is definitely a member of a timestamp. Now once you identify T.d, then you say that, oh, T.d by itself is a date. Then you will see that, oh, but that's not all, because we want to access the Y component or the Y member of a date. Then you have to look up and say, do we have a Y member inside the date? And then we do, because of the definition. So the compiler reads, just like we do, left to right, and then it goes from the largest, unit, and then we'll try to narrow down to the smallest member that you're trying to access.
On line 54, because you define D as date, which is the name of another record.
Correct.
A lot of that data.
Yeah, the uppercase date, refers to the name of the record type. Very good. So are we doing okay with this? This is still a long line, it just truncates it because I have this T here. Now how do we reverse it? Obviously we don't have time to do it in 10 minutes. But if you are to write a program or write subroutines to reverse this operation, I give you the epoch time. In other words, I give you a number like this, and you have to tell me, you have to convert this all the way back to year, month, day of month, hour, minute, and second. How would you go about doing it? Well, I will use a spreadsheet to do it, okay? Because this way I don't have to actually show you the algorithm, but we can at least understand the concept of how to approach the problem. I'm gonna use this sheet here, so I'll just use epoch as the name of that number, okay? Well, I can break it up into two big components like right away, okay? The two components that I want to break it up into would be the number of seconds of that particular day, and also the number of days since 1970, January 1st, midnight to this day. Okay. How do we break it up? Well, let's see, days versus seconds. Now this one involves the use of division and the mod operator. In order to find out the number of days, we can just take this number. Oops, excuse me. We can take this number and divide it by the number of seconds per day. So this would be the number of days since 1970, January 1st to the date that I'm interested in. The seconds is going to be a mod operator. So we're going to take the mod of this number and the same thing as the denominator, which is the number of seconds in a day. Are we doing okay so far? Breaking up into two main parts first. This part will eventually convert to a time record. This part will eventually convert to the date record. Are we doing okay so far with this? Okay. The second part is really easy to deal with because all we have to do now is to identify the hour, the minute, and the second within the minute. Well, let's deal with hour first. The hour is taking this number, okay, let me do the calculation, taking this number, it divided by 3600, which is the number of seconds per hour. It gives you a fractional number. If you do not like fractional number like this one, you can just say, I'm going to take the floor of that. Oops. Significance, we do have to specify the significance. Okay, it's 18. Now we have to identify the minute. The minute is a little bit more tricky to figure out because you have to first do the division and then do a mod after that. Okay, let me do this part here. So you have to divide this number by 60. But that would be the number of minutes since the beginning of the day to the time that I'm interested in. The hour part is done already. So what we need to do is to take a mod of this one. Let's see, this is the number of minutes.
Can't be right.
Why don't
There's more minutes. Those minutes, anything more than 60 minutes should have gone to hours. You have more than 60 minutes there.
Well, this is the number of minutes since the beginning of the day.
That's what I'm saying. You have like 1,119 minutes. 60 minutes should have added to 19 hours, shouldn't it?
Yes. So we have to subtract, the 18 hours that we have already accounted for. So that's the other way to do it. You can just subtract 18, which is this number, times 60. So that would be the minute of this hour. And once again, if you do not like the fractional number, you can just take the floor of this number, and now we have just 39. The number of seconds since the beginning of that minute is just this number. Is the mod, or the remainder of this number divided by 60. Are we doing okay so far with this? So we can now break it down. But is that right? I mean, was it really 18 or 6 p.m., 39 and 45?
It's UTC.
It's UTC, and UTC is how many hours ahead of us?
8.
Depending on whether we have a standard time or daylight saving time. Yep, so that's about right. All right, the days is the one that is difficult to deal with, okay? Because we have to boil down to which year we are dealing with first. Now, how do you boil this down to the year that we are dealing with? Why is that difficult? Why is it conceptually a little bit more difficult than converting the time, the number of seconds, back to hour, minute, second?
Because you have to account for leap years?
Because we have leap years, exactly.
Can we just divide by 365.25?
Not exactly, because that's not how we count the leap year and whatnot. So in order for this one to work, we'll have to do it the hard way, which means we have to start from 1970 and then decide, okay, 1970 is not a leap year, subtract 365. Okay, and then whatever is remaining, we have to subtract it with the number of days of the next year, and so on, until the number of days is less than or equal to 365. Then we can try to figure out the month and the day of month. So let me save this file first, because I think this one is really quite interesting, and we can continue with this, with at least the conceptual part of this on Thursday. So let me save this one as epoch.
That's for the 453 class.
Sorry?
That's for the 453 class or for our class?
Oh, you're right. For this class,
I'll just stick the same thing.
there we go. Save. All right, thank you. Alrighty.